As fronts bring clouds, before talking about fronts in detail, let's focus on understanding how the clouds form. We all know that the air contains a certain percentage of relative humidity. The term relative is referred to the corresponding temperature. Let's imagine, for instance, a small balloon inside which the relative humidity intended as the water vapour in a gaseous state is equivalent to 60%. If we now lower the temperature of this balloon full of air, the relative humidity will rise to 80%, eventually going up to even 100%, thus lowering the temperature further. The saturation is then reached. At this point, the condensation takes place, and the water vapour transforms into droplets, this leading to the formation of clouds. Then, summing up, every time the air cooling occurs, the relative humidity rises up to the saturation limit. Instead, in all other cases, when the air heats up, the clouds will fade and the relative humidity will decrease. We have explained that clouds form when the air tends to cool, and that this can occur, for example, when in a convective cloud the hot air rises, reaching a certain layer, the condensation level leads to the formation of clouds. However, this can also occur because of orographic reasons. In this case, we would talk about orographic clouds. When a wind clashes against a hill or a mountain, it is forced to rise, and when reaching a certain height, it cools down, giving way to a cloud formation. When the wind flows over this obstacle, it is subject to a sort of compression downwards, heating up, just like a bicycle pump that gets hot when we inflate the tyre. In the same way, the wind that is compressed downward will warm up and will disperse the clouds. However, the humidity that is left within the air mass at a certain distance as a wave pattern sets up will generate the typical altocumulus, lenticularis. They are very bright and white clouds against clear sky, a sign of a strong wind. Any time a sailor meets this type of clouds at sea, he will understand that a strong wind prevailing from the mainland areas is going to be forced toward the plain, and his further navigation will have to take account of this wind with its tendency to strengthen. To recognize all types of clouds is not easy, but we can at least try and identify their most important features. This is something we can do. For a start, we need to tell them according to the height where they form. There are low clouds, mid-level clouds and high clouds, getting up to 10,000 to 12,000 meters, up to the top level of the troposphere. Then we find isolated clouds, like this cloud, when they become cumulus clouds, as shown in this example. There are the stratified clouds, like the cirrostratus clouds, which are usually a foretelling sign of the arrival of a warm front bringing about rain, with the typical development of a warm front. In this case, the cumulus clouds can form both along the coasts and at sea, and are generally associated with the tail of a cold front. Therefore, when the pressure is about to rise, the air is relatively cooler, and these are the clouds that bring about fair weather in a way. These clouds instead are a sign of a strong wind aloft, usually forming on the leeward side of mountains when a strong wind climbs over them, bursting onto the sea. They are known as the sentinels of the sailors, as they indicate strong winds. They are bright and made up of ice crystals. They do not bring about any precipitation, but allow sailors observing them near the coast to understand the wind will strengthen, becoming very strong too. Generally, with the mistral, the bora, the northeasterly winds, precale, the clouds typically form on the lee side of a mountain. Their horizontal development is generally perpendicular to the direction of the wind coming from the mountain ridges. The cirrus clouds are high clouds. They are the first sign of the arrival of a warm front, an approaching mass of warm air. Being lighter, the warmer air rises to heights of 6,000, 7,000, 8,000, 10,000 meters. When these sky scratches filled with ice crystals do not bring about any precipitation, but they indicate that cloud cover is going to increase, with a high probability of rain. In this case, the pressure is decreasing too. The isolated cumulus clouds usually indicate fair weather. They tell us also that the instability is probable, and if they were to build up to a higher altitude in the towering form of an anvil, then they would transform from cumulus into cumulonimbus clouds. The cumulonimbus can lead to thunderstorms, though they are usually confined to the littoral zone during the afternoon and in a relatively fair weather situation. This is a congestus cumulus, that is a developing cumulus cloud rich of humidity. It forms when the air is more unstable under the cloud. In this case, some precipitation can fall, and a situation of unsettled weather is evolving. The mariner will have to pay great attention to the development and movement of these clouds. The low stratified clouds are often present in the sky. This can happen even in anticyclonic conditions. Then, for example, a yachtsman waking up in the morning and seeing the sky overcast with a light rain may decide to give up sailing because of the situation. But if he actually looked at it more closely, he would notice that the barometer would not show any variation, and that we are not dealing with a weather front, but just a stagnating humid air mass in the low layers. Once sailing offshore at a few miles from the coast, the sun would probably break through. The fog is a sign of stability. In meteorology, you describe as unstable the warm air in the lower layers, with a tendency to rise. You describe as stable, instead, in a situation when the cold air is already near the ground, with a tendency to stagnate and become heavier. The fog is the top condition of stability. It can form at sea, either in winter or summer, when the thermal differences between the sea surface and the air above are significant. The cumulonimbus is the typical thunderstorm cloud. In this case, the cumulonimbus develops with its typical anvil form. It rises to the high layers, slowly storing power from the whole surrounding air before suddenly discharging gusts and squalls. It usually forms along the coast during the afternoon, but if it were to form over the sea, this line of thunderstorms could represent the transit of a cold front. The cirrostratus and the stratus are stratified clouds generally associated with the transit of a warm front. When the sky around the sun or the moon becomes hazy, the cirrostratus clouds become opaque and you get a glimpse of sun in a translucent way. That's called halo. The halo is the indication that a warm front is approaching. As clouds thicken, this transparency keeps diminishing. The sky will remain darker until precipitation starts to fall. Even in this case, this series of altocumulus clouds indicate that a warm front is approaching. What will follow is the stratus clouds with some rainfall. This explains the correspondence with the saying of sailors and the situation that is generally studied in meteorology, actually confirming that a weather deterioration is about to occur.